All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are getting back to deep learning. And I'm really excited about that because for the past, I don't know, maybe it's been a month, as I started exploring the terminal based workflow much more and using TUI based apps and terminal based apps and command line tools and stuff like that, I kind of had to take a step away from deep learning just because I was kind of moving my workflow over to the terminal side. And now my workflow has pretty much moved completely. Has it? I'm not sure. I'm trying to think of situations where it hasn't moved to the terminal side, but like for the most part, I would say, yeah, my workflow has moved towards the terminal side almost completely. I'm not sure. Either way, a lot of it has moved over to the terminal side. And that being said, I think I'm ready to get back into doing machine learning stuff and data science stuff and deep learning stuff, especially. There was a ton of research that I was doing, deep learning related, that I'm now going to be able to carry on. And I feel like I'm going to be a lot more productive now with this workflow than I was previously. There are a few small differences in the way things are done. Give me a second. I just realized that I forgot to open up my stream manager on my phone so that I can see the chat. So give me a second while I open that up. Okay, cool. Great. So, um, here's what I've done so far. I've created this I've created a Python project for machine learning stuff, and within this project, wait, I don't have the. Oh, it's fine. We can enable the thing here. So source bin activate, and then here we can do pip freeze requirements dot txt. Okay, so once that finishes exporting, what did I just hit? Okay, yeah. So once that finishes exporting, is it done? Yeah, it's done. Okay, wait, I just realized, yeah, there's a bunch of like other dependencies as well. So okay, I've created a project for machine learning stuff. I should have actually named this deep learning because this is more specific to deep learning. But either way, I installed the basics stuff like numpy, pandas, matplotlib. I just realized that I forgot to install Seaborn. But I don't think that's absolutely necessary right now. Whenever I do need it, I can install it. And then of course we need IPython because for this workflow, IPython is definitely necessary. What I've got going on workflow wise is almost the same as what I was doing with Jupyter notebooks. But in Jupyter notebooks, or in a Jupyter notebook, you can create cells with text and cells with code, and you can run the code cells. Those code cells run in an IPython instance, which is running in the background. So that pretty much accomplishes the same thing. Just a second. I'm trying to remember. Oh, yeah. I need to open up the IPython thing here, I think. Wait, give me a second. I need to attach to the session. So Tmux attach T, and I believe the session name I'm looking for is stream desktop. Let me just see what, yeah, okay. Yeah, that's what I'm looking for. Now, here's something else that I was, oh, wait, shit, I need to be careful. I need to be careful of this. I just remembered that, yeah, this is also being streamed. But yeah, so this is where our IPython session is going to be running. And this is a separate session that I made to display images. Now, here's an idea that I had. I was thinking, what if I combined, I mean, I don't need to do that right now. I can just have them as separate sessions. But like, what if I combined um what if I brought the IPython session into the session that's running these 4 image display things? Because currently this is how I'm switching. Actually, no, that would not work out. No. Yeah, I just realized that would not work out because off stream when I'm doing deep learning stuff, I usually have this specific session displayed on another screen. So combining them like this is only going to benefit the stream, like when I'm streaming the coding session, but off stream, it's not really going to benefit. It's going to be more of a hindrance. Yeah, yeah. It's okay. I do need to go and rename the sessions, I think, because due to the requirement for some kind of graphics protocol, I had to move this session that has these 4 images, this session that I'm using for displaying images. I had to move this session over to a different machine. So now I should rename that session to this machine instead. Because currently it says stream laptop, because that's what I was assuming I was going to be doing. That's where I was assuming I was going to have this session open, but that is not true. And this session is called stream desktop because I was assuming that that is where I was going to have this session open, but that is not true either. You know what? Okay, we could rename the sessions right now. Rename session. Is this how you do it? I'm not sure. Actually, I think I'm gonna need to, okay, so this has to be stream laptop because this is gonna be running on the stream laptop. But for now, I'll put in _1. Okay, let's detach from the session and then let's attach to stream laptop _1. That is where we are now. Okay, great. So now I'm going to change this session's name, rename session, stream, what is this supposed to be? Desktop, stream desktop. Okay, cool. Let's also reattach to this stream desktop. Something that I liked was that it seems to attach to like the closest name that it can find. Like if you notice here, I don't know, I think it's pretty small, but the previous command that I had done was tmux attach -t stream lapto. I forgot the P at the end. Actually, I don't think I forgot the P. I think it's just this keyboard that I'm typing on. Sometimes certain keys their key press doesn't get registered. It's usually a sign that the keyboard itself is starting to go bad. It's not specific keys. It's just that in general, any key at any time, it might not register. Okay, so we got that session, we got this session, though now I can go back to the rename thing and what is this called? Laptop. Okay, so I can change this to actually laptop. Previously I had to put a hyphen, no, _1, just because there was already a session called stream laptop, so it wouldn't let me, I'm assuming it wouldn't have let me set duplicate names. But yeah, okay. Now that that is done, yeah, we don't need to have. I just realized that, yeah, we don't need to have the images shown right now. We can just have this. Also, something else that just occurred to me is that, okay, so how I'm showing the window that's in the bottom left corner is that that is actually running on Windows subsystem for Linux. So it's basically Linux on Windows, WSL. Um, and I, so that's a Linux instance that's running, and within that Linux instance, I have I've SSH'd into this machine, and that's how you're able to see whatever you're seeing, because I'm I've SSH'd into the machine and attached to a session that's running on a different machine. So what I could do is I could start up um, another Ubuntu instance as well and SSH into the same machine again, but this time connect to a different, this time I could connect to this IPython session, and then that way I could capture both of the windows separately in OBS and have both of them shown on screen. Though it's not really going to be too much of a, I mean, I think I'm just overthinking it. This is another thing that I've noticed when it comes to like doing things. I'll kind of like plan things out that, oh, okay, I could do this, I could do this, I could do this. Kind of like feature creep, kind of creeping in, if that makes sense. And sometimes it ends up being that I've done a whole bunch of work for situations that could have arisen but didn't actually arise. And so the work, the whole setup and all, it ends up being for very little. Not nothing, but for very little. I'm not sure how to explain that better, but like I've noticed that with a bunch of things that I've done. Okay, now let's talk about slime. Vim-Slime specifically. So I created helper um, this helper class kind of thing. Not even a class. It's just a helper module that has a bunch of, well, helper functions. And within this, so this is running in Python. These are functions that have been written in Python, and they're meant to be running in Python itself. And I'm super glad that I'm just able to import the entire module into my script, so I don't have to, like, do the whole creating a class and this and that, and I don't have to do something like, for example, having to send this entire code into the IPython interpreter. I can just do this import thing, and it just works. Where was I going with this? Yeah. So I realized something because this display helper class, I actually brought this in from another project, which is a project that I was doing in my last stream. It's a project that I had set up in my last stream. I'm considering pushing this script to GitHub because I feel like I'm going to be using this quite a bit. Or at the very least, maybe I could get this, maybe I could set up like a private repo or a local repo. I could set up a local repo and kind of have it hosted there because I feel like I'm going to be using this a lot. I kind of want to make a standard workflow, a standard setup that I could apply to multiple different scenarios. Currently, my two most common scenarios are data science and machine learning slash deep learning. Actually, data science and, well, let's say my three most common scenarios are data science, ML, and deep learning. And I wanna create a workflow and a setup that I can kind of apply to all of those kinds of projects. I don't want to end up having to change the setup for every single type of project. I want to create a workflow and a setup that can be used in all of those situations. So it kind of saves setup time. It saves like it makes it so I can just create a project and quickly get to work. So this is one of the solutions to that. Just a second. I think I need to change a name here. So I just changed this, right? Yeah. So here, this needs to go to stream desktop, not to stream laptop. And then we have the command window and the display window. Oh, yeah. Okay, stream desktop is different. Yes, stream desktop is different. And we need to do, I'm just trying to recall all of this stuff. So in config, we have to do this, and then we want to send these commands over to stream laptop. Yeah, we want to send this over to stream laptop, IPython window, pane 0. Okay, great. Now, just to test that it's working, we can exit. I don't know. Did that work? No, I'm not sure where that sent. Oh, hold on. Shit. Wait, hold on. This is supposed to be stream laptop. This is supposed to go to stream laptop, not stream desktop. Okay, give that a second. It's exiting. Great. Awesome. And now we can enter IPython again. Okay. So then here I need to change the thing. No, I don't. Okay, this is stream desktop and then that is stream laptop. Yeah, I had a bit of a confusion because I just changed the session names. Okay, now I don't know how far we are going to be going, how much progress we're going to make during this stream, but something that I do want to at least start doing is I want to start looking at exporting to ONNX, exporting to the ONNX runtime. Give me a second. Check. Hello? Testing. Yeah, okay, we're fine. So something that I do want to kind of start looking into. I've actually looked into this before, but kind of just, just a glance. I didn't really go too deep into it. But yeah, something I would like to look into is exporting exporting a PyTorch model to the ONNX format, and then also running an ONNX model, because at this point it's going to be an ONNX model, running an ONNX model in an IPython, no, running an ru- words running an ONNX model in the ONNX runtime. What is going on, dude? Okay, hold on just a second. Yeah, all right. Yeah, so that's my goal currently. And once I'm comfortable with exporting a PyTorch model to ONNX and then running an ONNX model in an ONNX runtime in Python, maybe I can explore running it in Rust as well. But I think just being able to run it in Python is also gonna provide a significant um, performance boost, a significant performance gain, because at least from what I've understood, the ONNX implementation apparently isn't pure Python, which in this case is a good thing. The ONNX implementation is in C, C++, and your Python code is kind of calling into that code. So you're still gonna get the performance benefits, and you're gonna get stuff like benefits from multi-threading, for example. So once I'm comfortable with doing ONNX stuff, then I want to explore subprocesses, the subprocess module. I want to this module, this one. I want to explore the subprocess module, because this is what we're going to be using to spawn uh, multiple processes, each of which is going to host one ONNX runtime instance. And so we can have, I don't know, maybe four that are running, depending on, what's going on with the system's resources and stuff. I'm so initially I was considering doing hold on. Let me go to, where was it? Oh, wait, this is showing all the windows. Hold on. Hold on. This. So, initially I was gonna do the multi-threaded version. Wait, are you guys able to see this? Yeah, you're able to see. Okay. Initially, I was going to do the multi-threaded version and then a distributed version. I was also planning on doing a simple version, but I kind of feel like I'm going to be able to set up the simple version anyways. So the simple version is probably going to end up being a waste of time. I don't know. I could be wrong about that. I'm still tempted to make a simple version. Here's the thing, though. If I'm running this in the ONNX runtime, like, this just occurred to me. If I am running this in the ONNX runtime, um, and the ONNX runtime, which is implemented in C, C++, not in Python, the ONNX runtime does give you options for setting the number of threads for inter-op multi-threading and intra-op multi-threading as well. If it's anyways giving you the options for that, then is there really a point in having multiple processes that do stuff with it? That multiple ONNX runtime instances, basically. Is there really a point to having multiple processes, each of which is going to be running one ONNX runtime instance? I guess the answer to that would be, or to answer that question, I'm going to have to properly understand how well the interop and intra-op options are really going to benefit the Kokoro TTS model. I'm guessing other people might have come up with their own, optimal settings that. Yeah, I feel like there's a lot to explore there, because in order to actually benefit from interop and intra-op multi-threading, the model has to actually, you know, be able to use multiple threads, or rather, the ONNX runtime should be able to divide one operation into multiple smaller operations, or even one graph into multiple smaller operations that can then be executed in parallel. But like, if the architecture of the model doesn't really allow that, I shouldn't say allow, but like, if the architecture of the model is designed in such a way that the ONNX runtime is not able to divide those operations up, um, then I think I would benefit from um, having multiple processes that would run the ONNX, uh, each run a separate ONNX runtime instance. Yeah, yeah. You know what? I'll keep that option open. I'll make it multi-threaded at first, because I mean, eventually the goal is to create a distributed system, because I do have multiple systems, and each of those systems use can actually, devote some of their resources towards running the Kokoro TTS model. Yeah, hold on. I just realized I'm having that issue again, where I'm the only one talking right now and there's no background sound. Usually I have somebody's stream running in the background, but like, because of internet issues, the stream that I had running, currently I have Zentrea's stream running on another machine, but because of the internet issues, Zen's stream keeps buffering. So there wasn't any sound coming in. So I've refreshed the page. Give me a second. Okay. All right. Now, what was I saying? Yeah, I was wondering if I should bother with like the simple version and the multi-threaded version, but I think yeah, let's do the multi-threaded version first, because the multi-threaded version, it's gonna, if anything, it's gonna tell me whether dividing up the operation into multiple threads would benefit this entire system in any way at all. And if it would, then I think I can put in the extra time and effort to create a distributed system, which would then use multiple machines on the network. Yeah, yeah, I can do that. I can do that. Definitely, I can do that. Sorry, zoned out. Okay, so um, okay, right. So we have a display helper class, which I'm gonna need to push this to GitHub because I'm gonna need this in pretty much all of my data science and ML and deep learning related projects if I want to be able to benefit from multiple screens. Which yes, I want to be able to benefit from multiple screens. I don't know if I mentioned this in the previous stream, but something else occurred to me um, recently, and that is I can run because I'm doing this thing in like Tmux, so I can benefit from like multiple different processes or multiple different shells. So for example, let's say I wanna start the training process of a model. I can start one IPython instance and have the training running in that, but then I can also have another IPython instance in which I'm doing other stuff. Each of these is running on each of these is a different process, right? So they're not going to interfere with each other, and I feel like I'll be able to get quite a lot done in that way, not having to pause the work. Okay, so this is the display helper class. Another class that I felt like I would need is this class, but this class is not going to be like I've created this as a Python file, just so that I can just so that it triggers Vim-Slime to work as well. But this doesn't necessarily have to be, and okay, not just Vim-Slime to be fair. Actually, no, nothing Python related. Specifically, I wanted Vim-Slime to be triggered. I think that was the reason why I named this, why I gave this a Python extension, even though everything in this script is meant to be running outside of Python. None of this is going to be Python code. Um, yeah. So I need to. I forgot what exactly I was going to be running here. I think here I needed commands for IPython just to be able to do a lot of the setup from within here itself. Um, as in from within this one file, as opposed to having to go into that specific session and typing stuff out. For example, um, let's say I create a new, let's say I exit from here, and you know what? Yeah, we can do that. We can do that. What is it? mlproj o2. Okay. Let's deactivate. Okay, just excuse that whole thing. And then cd into the home directory. Um, Now, here's kind of what I want to set up. Okay. It's going to be C. Dude, I'm wondering if I need. Yeah, yeah. No, I need it because I need without it being a Python file. Um, it's not gonna Without it being a Python file, it's not gonna trigger um, Vim-Slime to activate, and then I'm gonna have to open up an actual Python file to kind of trigger the thing. But another problem is that if I start writing out code here, if I start writing out shell commands here, then Pyrite and Rough are going to be giving errors, which it's not really that big of a deal because they don't actively, you know, occlude anything. They don't obstruct the view. They just put their messages at the end of the line. Okay, so here what I want is cd what is it? Work VS Code. Okay, VS Code projects. Python. I like that it's completing the thing for me. I wonder where that's coming from. But yeah, I like that it's doing that. MLproj 02. So we want to cd into that, right? Once we've cd'd into that, okay, usually what I would do is I would like write out one very long kind of thing, one very long statement with like a bunch of, ampersand signs. So it executes one, and when that's successful, it executes the next one. And when that's successful, it executes the next one. But I think in this case, I'll write them out separately. So we cd into that, and then we want to activate the environment. So we do activate, right? And then within that, we want to call IPython. I feel like I might need to create this kind of script. No. So this is something else that I'm trying to do. It's that, and there's the errors that I was talking about. But yeah, okay. Something else that I'm trying to do is, aside from just display helper, I'm wondering if I should also have this slime helper thing. And within slime helper, I'm just going to have a bunch of these like bash commands that'll, for example, take us to the home directory, and then we can cd into whatever the project is. And after that, activate the environment and open up IPython. I feel like depending on what the project is, the only thing I'm going to need to do is change this path. But other than that, all the other commands are going to remain the same. Maybe I need to change this comment. I'd written something in here. I don't remember exactly. Hold on. Do not import this file as a module. These are blocks of code meant to be executed in the Tmux session that's supposed to be running the IPython instance. Okay. These blocks of code help with activating and deactivating the environment. Yeah, okay. That's that. Oh, so then we can have a bunch of like extra commands in here as well. So we can have exit, we can have deactivate. Is there anything else? I don't know, pip3 freeze requirements .txt. And yeah, I guess that's it. Okay, so now we can run each of these commands. So let's run that. Think we need to do the setup again. This is what stream laptop. Oh, that's interesting. So this is per, I think this is per buffer. Per buffer, we have to do this kind of setup. I thought it was per project or per Neovim instance. Okay, cool. I'm not complaining about that. What is it? IPython, and it is stream laptop. That's where we are sending this. Okay, there it is. So we sent cd, then we're gonna cd into the project directory, then we're gonna activate the environment, then we're gonna open up IPython, and we are in. Great. So I'm gonna need to hold on to, or well, I'm holding on to it anyways. I'm gonna need to keep this. Should I leave it as a Python file? Because this is gonna contribute to like the whole list of errors. For example, if I do this, I'm gonna be seeing all of these errors. To be fair, I could also just when I'm opening up these kinds of things, I could just do like specific to, wait, hold on. Why did that not work? No results for diagnostics. Okay. Oh, because there's nothing wrong here. So it has nothing to show. Okay. All right. Yeah, I could just do per buffer. That's not an issue. I could do that. What was the thing for just a minute. There was a thing for okay, this is to so, oh, I forgot about that. Yeah, I'm kind of used to doing so just now I'm pressing shift and H to and also shift and L to move to the buffer on the left or move to the buffer on the right. But there was also another thing to actually move the buffer. Also, yeah, I'm doing shift H and shift L, but what I'm used to is square bracket B as an open square bracket B and open square close square wow, close square bracket B to switch the buffers. And you can also, in this way, you can also move the buffers. For example, I could move this specific buffer to the second place in the list, like that. Yeah, that's kind of what I'm used to. Though I keep forgetting that Shift H and Shift L are options. I'm just used to doing this. Anyways, so we are gonna close that, and what are we looking at here? Yeah, I don't need this. I don't need this stuff anymore. So I can just delete all of this. What is it? 10 lines? Yeah. Okay. Um, import could not be resolved. Yeah, that's fine. That's okay. Now I'm gonna run this, and then I can also run this. Okay, that is our IPython session running. So when I was talking about like the workflow, I want to have a standard workflow. I need to sit down and think about. I think I'm only gonna be able to. I'm only words. I think I'm only gonna be able to figure out a good workflow once I've actually done the work. So I need to start doing a bunch of data science work and a bunch of deep learning work in Neovim, in Tmux, using this whole workflow. And only then will I know exactly what I need. Because right now, what I'm thinking is, so you guys can see the IPython session running here. This IPython session is running. This IPython instance is running in a Tmux session called Stream Laptop. So this session is not meant to be running. This Tmux session is not meant to be running on the system that it's currently running on. It's only running on this system so that I can actually stream it to you guys. Generally, this specific session would be running on on another laptop, which is the laptop from which I'm streaming to Twitch. Yeah, that stream laptop session is meant to be actually running on my streaming laptop. And then I have this, which is stream desktop, which is meant to be running on the desktop that it's currently running on. But what I'm doing is I'm capturing the video feed and streaming it to an RTMP server, and then from my stream laptop, I'm I'm pulling that RTMP feed, and that is why you guys are able to see this kind of stuff. That is why you have this window, because this is what's being shown on that specific machine. I forgot why I was explaining this. Sessions like in mind, these multiple sessions set up. hold on. Let me also show you guys. There's one more session, Tmux ls. There's one more session on a machine called other desktop. And I haven't done much with that session yet because I'm supposed to be accessing that session on a very old desktop of mine. And that is like if I need an extra screen for whatever reason. That's why I've made that one session. Okay. All right. Just a second. Yeah. Okay. Okay. So in terms of making it a sort of standard process, I'm wondering if I could probably benefit from like multiple IPython instances. But then I feel like that would become a little bit I feel like that would become a little bit confusing. Yeah, no, maybe I shouldn't be doing that. Cuz like what I was wondering is like let's say uh like what I described earlier, let's say there's a situation where I want let's say there's a situation where I want to send no, I feel like yeah, no. Maybe in that specific instance, I could do like I could do the thing manually instead of trying to make that a part of the standard setup. But like if things do get complicated, then yeah, I could make it a part of the setup. But I don't think that's going to be necessary. So like for example, if there is a situation where I need to run training code, I could just create a separate IPython instance. As in, I could create a separate window. In fact, I could create a separate window, open up IPython within that window, and then start the training, and then come back to this IPython window. Yeah, yeah, I could do that. I could do that. Yeah, yeah. I feel like I need to know when to stop with the automation. Like in terms of trying to automate things, when I need to stop, because otherwise I'm going to spend more time trying to automate the work than actually doing the work. Yeah, yeah. You know what? We are good for now. Um, I think I do need to install. Hold on. So let's read this. Also, good news. The PyTorch website finally got dark mode. This is the one, right? Yeah. It finally got dark mode, so we have this now. I need to find a way to get rid of this thing. Though I'm wondering if this happened because I moved the tabs to the sidebar instead of having them up. Okay, whatever. Okay. Um oh, you know what I could do? F11. That'll give me a little more real estate to work with. Okay. Um I was gonna ask Gemini a question. So give me a second while I set that up. Okay, so what I was gonna ask was, okay, so I'm doing PyTorch research, more specifically, learning how to export a simple feed-forward neural network. What is it, FCNN or FFNN? Yeah, I think FCNN works, right? Because it's a fully connected neural network. Okay, a simple feed-forward neural network. What more specifically, learning how to export a simple feed-forward neural network to the ONNX format. I could just write a very simple neural network class, but what I'm wondering is, are there any example, any simple, any very, any very simple example NNs provided that I could use instead? Yes, PyTorch provides a very simple way to create. Oh shit, I forgot about that. Yeah, dude. Wait, no. You still need the forward function, don't you? Yeah, you still need, well, you need a forward function to actually run the thing, right? No. Well, yeah. Yeah, I think you need the forward method gets executed when you call the class as like a function. That's when the thing gets executed. But like if it's just, because like sequential gets used within the neural network class. So you would do something like, for example, where's my window? Here. So you would do something like, wait, do I have torch? Yeah, I do. Okay. Import torch.nn as nn. So you would do something like class my nn01, and then this has to inherit from nn.module. And then in here, we define the init method, which I'm glad that it already has all of these things set up. I need to look into those other arguments. But yeah, okay. Then we do self dot flatten equals nn dot flatten. So that's our flatten function that we're going to be calling. Then we do self dot linear relu stack. This is literally just me parroting the entire, like, whatever example we have learned. In here we do nn.sequential, and within that we define our entire network structure. So it could be nn.linear, and we give it, I don't know, 5 and 10, and then we can do nn.relu. I don't remember if we need to specify features yet. No, I don't think we need to. Okay. Then again, linear, this takes in that many features and then gives out that many. And then we can do relu again. Actually, okay, we don't, no, we can do it. It's fine. And then we can have another thing here, and that could give out 1, I think. I think so. Right. And then here we do forward. And it's not self. I don't think we need self in this case. So, oh, we need self. Self, no, x equals self dot flatten x, and then logits equals self dot. Why am I sitting and writing down the entire fucking network? Okay, anyways. Linear relu stack. We pass in x, and finally we return logits. After this is done, I believe we get the softmax of this, but we don't get the softmax within the network. We get it like from the results. I believe so. Yeah, because we are returning logits, and the logits are what get passed into the softmax function to give you probabilities. Right. Yeah. So this is then going to be our network, and we can create the network by doing, let's say, model O1 equals my nn O1, and yeah, that's our network. We can have input where's tensor? I don't remember. From torch import, yeah, tensor. So we can do input equals tensor. Okay, I'm gonna need to remember the shapes again, because I remember always having this issue where I have to remember the shape, but like depending on the shape of the neural network itself. Okay, hold on. I'm reading the thing that Gemini told me. So, using torch.nn.sequential. The sequential module allows you to build a neural network by passing an ordered list of layers, and the data will be fed through them in the same order. This is a great choice for simple models like an FCNN because it handles the forward pass automatically. Okay, you know what? That works. That works. So what Gemini is suggesting. Actually, I think I need to have the ONNX runtime installed, don't I? Wait, let me ask the question here. Actually, wait. There was something that I wanted to test. I don't know if it's gonna work. Okay, you know what? I'll test it. I'll test it for the next stream. Okay. If I want to run ONNX models in Python, and I already have PyTorch installed, do I still need to install a separate ONNX runtime package? Yeah. Or does PyTorch have something I can use? Because I know you can export the model using it, but um, what about running inference? Yes, you still need to install a separate ONNX runtime package. Although PyTorch has built-in support for exporting models to the ONNX format via torch.onnx.export, it does not include the necessary runtime to actually run or perform inference on an ONNX model. Why you need ONNX runtime? ONNX runtime, yeah, I just remember, dude. The ONNX runtime is it's uh, it's talking to the C++ library, as in the ONNX Python code would be talking to the C++ side. So it kind of seems better if that would be part of. I mean, that could still be included in PyTorch, but then like they would be doing the development of that, and like it doesn't make like why would they need to do that when there's already my I'm just saying shit. I'm just saying my thoughts out loud. Um, yeah, it's a separate thing. It's not necessarily part of it. Okay. Why you need ONNX runtime? ONNX runtime is a high performance inference and training accelerator for machine learning. I should look into the training side of ONNX as well. Yes, I should definitely look into the training side. This did not occur to me. I should look into the training side of ONNX to see if there's like any difference between training a model in PyTorch and then exporting to ONNX versus building the model, exporting it to ONNX, and then training it in ONNX. Okay, where was I? Yeah, inference and training accelerator for machine learning models. It's designed to run ONNX models efficiently across different hardware and operating systems. Okay, sorry, I got distracted for a second. Uh, right, so it's giving me all of the features of the ONNX runtime, which is fine. That's great. But yeah, let's go over to this. Does this also have a dark mode? Let's go, dude. Hell yeah. Okay, why PyTorch plus ONNX runtime? Native support in PyTorch. PyTorch includes support for ONNX through the torch.onnx APIs to simplify exporting your PyTorch model to the portable ONNX format. The ONNX runtime team maintains these exporter APIs to ensure a high level of compatibility with PyTorch models. Production ready. Train and deploy models. Yes. Okay. Hold on. There's the question. Okay. So here's a thought that, or here's a question that came up in my mind when dealing with ONNX stuff. What would be the difference between building a PyTorch model, training it in PyTorch, and then exporting it to the ONNX format versus building a PyTorch model, exporting it to the ONNX format, and then using ONNX to train the model. Let's see what the response is. This is an excellent and insightful question that gets to the heart of what ONNX is 4. Okay. The difference is significant. ONNX is primarily an inference format, not a training network. Workflow. The standard workflow is build in PyTorch, train in PyTorch, export to ONNX. This is a standard and most common workflow. PyTorch is an end-to-end framework, meaning it's built to handle every part of the machine learning lifecycle, from building the model's architecture to training it and what? Hold on. From building, where was I? Yeah, from building the model's architecture to training it with optimizers and loss functions. After the model is trained, its parameters are finalized. What? After the model is trained and its parameters are finalized, you use the torch.onnx.export tool to convert the trained model's graph and weights into the ONNX format. The ONNX model is then ready for inference and deployment. Workflow 2, which is non-standard, is build in PyTorch, export to ONNX, and then train in ONNX. This workflow is generally not recommended or even feasible for most models, while ONNX runtime does have some experimental. Oh, okay. I didn't know it's experimental. Okay, so while ONNX runtime does have some experimental support for training called ORT training, it is not a complete general purpose training solution like PyTorch or TensorFlow. ONNX runtime's training features are typically used for niche cases such as on-device training or for accelerating the training of very large models by leveraging ONNX runtime's highly optimized backend. It's not a replacement for the robust, full-featured training environment provided by PyTorch. When you export a model to ONNX, you essentially capture a static computation graph of the model's forward pass. Training, on the other hand, um, requires a dynamic graph. Requires a dynamic graph that includes the backward pass for calculating gradients and the optimizer's state for updating weights. While ONNX runtime can generate these components, it's not as flexible or mature as PyTorch's native training loop. Okay, okay, cool. All right, so PyTorch plus ONNX runtime. Okay, okay, okay. Where is get your PyTorch models ready for so and so native PyTorch support? Okay, cool. Let's open this up. Give me a second. Okay, there are two Python packages. Hold on, chill out. Wait, yeah, there are two Python packages for ONNX runtime. Only one of these packages should be installed at a time in any one environment. The GPU package encompasses most of the CPU functionality. Okay, in this situation, I'm not using the GPU. Something I should look into, which I don't think it's gonna work. I don't think that's gonna be the case because like it's using different types of hardware. But like I was wondering if Intel's inbuilt GPU could be used as well for running inference. I know that that's possible with the newer. Actually, is that no? Is that possible with the newer GPU with the newer CPUs? As in the newer CPUs built-in GPUs, or was it Intel's own GPUs that I'm remembering? Maybe I'm remembering it wrong. I don't remember. Okay, anyways. Yeah, I don't think I'm going to be installing the GPU version. I think I'll stick with the CPU version. Besides the CPU version, at least for like PyTorch, it tends to be much smaller. So I'm assuming even for the ONNX runtime, it's going to be much smaller. Install ONNX for model export. Torch TF2. I don't think I need that. Oh, wait, no, this is for scikit-learn. I didn't know that there was a scikit-learn version as well. I should try that. I should try that for something like um, linear regression. I don't use TensorFlow. I use PyTorch. Okay, cool, cool. So, um, wait, wasn't there a dark mode? Where did that go? Okay, whatever. I need to go back out and install the ONNX runtime and then come back in. Yeah, I just realized something. An ONNX graph doesn't necessarily have to contain like a full-fledged uh, neural network, right? Because the graph can contain like the graph can contain because the graph has multiple like nodes. All of the operations in the graph get broken up into nodes. Um, so I could just export those individual operations, right? Like for example, linear alone. I think I could export that as well, and it would accept it. I think I should also have Netron open so that we can. Oh wait, no, I'm not going to be able to. Yeah, no, never mind. Because I was going to be like, okay, I want to be able to visualize the graph for the network, but the thing is, I would be running because like this browser that's open right now, um, I'm not doing any of the Python coding on this machine. All of this coding is being done through another machine on another machine, and it's just being displayed on this machine. That's that's the beauty of Tmux. But yeah, yeah, I need to see how to go about doing that. I should also see if there are any TUI based. Yeah, yeah, yeah. You know what? Hold on. That's a good question. Okay, so I recently moved the majority of my workflow over to the terminal and TUI based apps. I know that there is um, a web app called Netron that can be used to visualize um, that can be used to visualize ONNX ONNX graphs. But I'm wondering if what am I wondering? I'm wondering if there are any such TUI based tools. Because dude, Netron is amazing. It is amazing. Like if you are trying to learn how networks get first of all, like broken up into different types of operations in ONNX. But also, if you're just trying to learn in general how all of these different operations work and what's going on within a specific model, all of that is possible through Netron. Because Netron will give you it'll give you like a graph view of your entire network, and you can select each of the nodes and the connections between the nodes, and it'll show you like values. Like the simplest examples that I can give are stuff like weights and biases, but it also it also gives you a bunch of other information, stuff like shape, the shape of the shape of the input tensor expected, for example. Okay, this is a great question and highlights a common need for those who prefer working in a command line environment. Why do I feel like the answer is going to be no? While a direct, full-featured TUI that provides an interactive node and edge graph visualization of an ONNX model is not as common as a web-based one like Netron, there are a few tools and methods you can use to inspect and visualize an ONNX graph from the terminal. The key is to leverage existing command line tools that can generate a graph visualization which can be viewed with a command line image viewer. A command line image viewer. So like ICAT, for example. Okay, so there's something called ONNX CLI. This is a very powerful and direct tool for working with ONNX models from the terminal. It's a Python package that provides various subcommands, including one for drawing a graph. How it works. ONNX CLI can draw the ONNX graph in different formats like .svg and .svg or PNG. I need to see how Kitty's ICAT handles SVGs. I think I should also look into dot. Yeah, okay. You would then use another terminal utility to view the resulting image. So this is going to be an image. Okay, all right. So we install this and then we use something called GraphViz, which is required by ONNX CLI to render the graph. Okay, draw the ONNX model to a PNG file or to an SVG file, and then viewing the output. Once you have the image file, you can view it directly in the terminal using an image viewer that supports TUI or a simple frame buffer viewer. Okay, all right. Manual Python scripting with PyDot. If you prefer more control, you can create a simple Python script to do the same thing. The ONNX package itself provides some helper functions that work with PyDot, a Python interface to GraphViz. What is? Hold on, I need to look up all of these things. Wait, give me a second. Dude, I just realized something. Each time that I've been doing this, I did not need to do that. I could have just I could have just done this instead. Yeah. But yeah, okay. So, what I'm trying to do here, give me a second. Okay, first things first, I'm looking for ONNX CLI. Um, Hold on a second. Okay. Then I'm also looking for GraphViz. GraphViz is an open source graph visualization software. Graph visualization is a way of representing structural information. Okay, let's open this thing up, and let's also open up. Where's the GitHub? Is there a GitHub for this? Yep, there it is. And what? Yeah, let's also look at PyDot. Uh, just a second. Let's come back here and enable this again. Okay, cool. Okay, GraphViz is an open source graph visualization software. Graph visualization is a way of representing structural information as diagrams of abstract graphs and networks. It has important applications in networking, bioinformatics, um, software engineering, database and web design, machine learning, and in visual interfaces for other technical domains. Okay, so what's this about dot? Abstract grammar for defining GraphViz nodes. Oh, okay. Right, so they've given another workflow. Well, I mean, what do you call it? Gemini. Gemini has given another possible workflow that could be followed. Dude, give me a second. I'm yawning for some reason. Okay. Um, Terminals are shown in bold font, and non-terminals in italics. Literal characters are so and so, so and so. Okay, hold on. Okay, I'm gonna finish reading what Gemini had said. So why not a direct TUI? The reason there isn't a single widely used TUI that provides a beautiful interactive graph like Netron is due to the inherent complexity of rendering complex. Actually, yeah, I understand that. I understand that because what I've seen so far in Netron was the simpler graphs, but there are like way more complex. Um, there are way more complex network architectures that you can view within Netron, and it at least from what I've seen, it does a decent job. I haven't seen like I don't understand the most complex neural network architectures, so I can't say for sure that it has render them accurately, but it does render quite a bit. Not only that, it also renders different formats, not just ONNX, from what I understand. I went for ONNX, but it does support other stuff as well. Um, where was I? Interactive graph like Netron is due to the inherent complexity of rendering complex multi-layered graphs in a text-based environment. A tool like Netron benefits from a rich graphical interface to handle panning, zooming, and clicking on individual nodes to view their properties. Okay, you know what? I mean, um, that's not like a huge deal breaker. Something that I could do is I could just have the way that I have this um, this browser running. I could just open up another browser and view the thing there. I could do that. Or yeah, we could also just like we could follow this method of like getting a static image that'll give us sort of an idea of what the architecture looks like. It'll allow us to visualize the architecture to a certain extent. Where was I? A tool like Netron benefits from a rich graphical interface to handle panning, zooming, and clicking on individual nodes to view their properties. Replicating that kind of user experience in a TUI, while not impossible, is a significant technical challenge. Okay, for terminal-centric workflow, the generate and view approach with tools like ONNX CLI and GraphViz is the most practical and efficient solution. Okay, so you mentioned dot a couple of times. Um, I looked up GraphViz, and it seems like it's a framework for generating graphs, um, and it has its own way of generating graphs. I also noticed dot being mentioned there. Explain GraphViz and dot to me. Okay, GraphViz is an open source graph visualization software package that uses a descriptive language called dot to generate visual representations of graphs. Think of it as a compiler for diagrams you write. No, think of it as a compiler for diagrams. You write the structure of your graph in the human readable dot language, and GraphViz compiles it into an image like PNG, SVG, or PDF. Okay. What is a graph? In the context of GraphViz and dot, a graph is a collection of nodes and edges that connect them. Okay, I thought there was more to the sentence. Okay, a graph is a collection of nodes and edges that connect them. This is a mathematical concept used to represent relationships between objects. This is not the same as the graphs you might have seen in algebra, like line charts or bar graphs. A node represents an entity. An edge represents a connection or relationship between two nodes. There are two main types of graphs you can create with dot: directed graphs, where edges have a direction represented by arrows, for example, a flowchart or a family tree. These are defined. Dude, I feel like I could use this for other purposes as well. Shit, this just occurred to me. I feel like I could use this for other purposes as well. But yeah, a flowchart or a family tree, these are defined with the keyword digraph. Oh, as in directed graph. And then undirected graphs, where edges have no direction, represented by simple lines. For example, a social network where friendships are mutual. Oh, so one is showing like flow from one point to another, but the other is just showing a connection. Okay, okay. These are defined with the keyword graph. What is dot? Dot is the language you use to describe your graph. It's a plain text. It's a plain text format that's easy to write and read. Wait, you can just write this out? Okay, that's interesting. Okay, we could do something fun with this. Yeah, we could do. Dude, actually, I could probably use this to create like a diagram of how I'm setting up my um my entire like data science workflow with Tmux and stuff. I could do that. I could do that. Okay, anyways. Um all right, so that's Dot. Why are GraphViz and Dot so useful? They provide a simple text-based way to create complex data. Okay, so what I'm getting here is that Dot is a language that actually describes the graph in a human readable way, and then GraphViz is what is able to parse that language and generate a proper graph out of it. Okay. They provide a simple text-based way to create complex diagrams. This makes them ideal for automation, version control, interoperability. Okay. All right. Cool. Okay. So this is an option for us. This is definitely an option that we can explore if we absolutely need to like dive deep into the neural networks, bits and pieces, then yeah, we could use Netron. Otherwise, we could very well just use this. I should look into um okay, Kitty iCat SVG. Um okay, so apparently it can open SVG files. Okay, hold on. Just a second. Okay, so there's someone doing something called Python PCEP certification study. I'm not sure what that stands for. Um, Either way, we're gonna go over to them. Um, just a second. Let me. Right. Okay. So that's gonna be it for today's stream. I'm gonna try and stream again tomorrow. I do want to make this a regular thing, but like, holy shit, dude, I get busy sometimes, and sometimes because of my own carelessness, I miss the opportunity. I miss the window of opportunity where I'm gonna be able to stream. Um, Hopefully, after we set up the TTS, that whole window of opportunity thing will not be as big of a problem, because then I'm just going to be able to, you know, use TTS in situations where I'm not able to do a talking stream. I'm looking forward to that. But yeah, okay, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.